Hi guys! Welcome to my channel. So, thank you for subscribing. So, due to your public demand, you want me to discuss about sets and the types of set, specifically the finite and infinite set. Okay? But before we go through to set, let us first discuss a brief history of sets. So, the theory of sets was developed by a German mathematician, Georg Cantor. He first encountered sets while working on problems on trigonometric series. Sets are being used in mathematics problems since they were discovered. So siya di ay ang nag-discover sa set, Georg Cantor. Okay, so let's define a set. So what is set, by the way? The collection of well-defined distinct objects is known as a set. The word well-defined refers to a specific property which makes it easy to identify whether the given object belongs to the set or not. For example, the collection of children in class 7 whose weight exceeds 35 kilograms represent a set. Why? Because this means that we're going to collect those students who exceed 35 kilograms. So it represents a set. So another, the collection of all the intelligent children in class 7 does not represent a set. Because the word intelligent is vague. What may appear intelligent to one person may not appear intelligent to another person, right? So how to state that whether the object form a set or not? For example, a group of young singers. So it form a set or not? It is not a set. Why? Because as the range of ages of young singer is not given, and so it can't be decided that which singer is to be considered young or not, right? So the objects are not well defined. Second example, a group of players with ages between 18 years and 25 years. So it is a set because the range of ages of the player is given, and so it can easily be decided that which player is to be included and excluded. Hence, the objects are well defined. So let's proceed to the notation of set. So note that the pair of curly braces denotes a set. So the elements of a set are written inside a pair of curly braces separated by commas. The set is always represented by a capital letters. And if the elements of the set are alphabets, then these elements are written in small letters. So if we're going to name a set, it should be in a capital letters because it is always that the elements of a set, if it is in alphabet, it should always be in small letters. The elements of a set may be written in order, so order is not important. Order in elements in the set is not important. The elements of a set must not be repeated, so dili siya pwede magbalik-balik, not repeated. So the Greek letter, this one, is used for the words belongs to, is an element of. Therefore, X is an element of A, will be read as X belongs to set A, or X is an element of set A. So this symbol stands for does not belongs to, also for it's not an element of. Therefore, this will be read as X does not belong to set A, or X is not an element of set A. So the objects used to form a set are called its elements and its member. Generally, the elements of a set are written inside a pair of curly or idle braces and are represented by a commas. The name of the set is always written in capital letters. Diba? As I told you, always be in capital letters. Okay, solve examples to find elements of members of a set. So this one example. Here, A is the name of set whose elements members are W, V, X, Y, and Z. Example number 2, this one. So state whether the following statements are true or false. Okay, 7 is an element of A. So it is true or false? So it is false because the element 7 does not belong to the given set A. How about this one? Okay, 10 is not an element of A. It is false since the element 10 belongs to a given set A. Okay, let's proceed to the cardinal number of a set. So what do you mean by the cardinal number of a set? So the number of a distinct elements in a finite set is called its cardinal number. It is denoted as this symbol and as read as the number of elements of the set. Okay, for example, set A, they have 2, 4, 5, 9, and 15. So we're going to count, it has 5 elements. So therefore, the cardinal number of set A is equal to 5. So it is denoted as the number of elements in set A is equal to 5. Second example, it has W, X, Y, and Z. So it has 4 elements. So the cardinal number of set B is equal to 4. Another example, set C. We have Florida, New York, California. So it has 3 elements. Therefore, the cardinal number of set C is equal to 3. So it is denoted as this one. Set D. So the 3 is repeated and 7. So we're just going to count it as 1. So we have 1, 2, 3, 4, and 5. So it has 5 elements. How about this one? Empty set has no element. Therefore, the cardinal number of set D is equal to 0. So it has denoted as the cardinal number of set D is equal to 0. Note that the cardinal number of an infinite set is not defined. And the cardinal number of empty set is 0 because it has no element. So let's proceed to the representation of a set. So we have a statement form, the roster or the tabular form, and lastly the set builder notation. So first, let us have an example of a statement form. It is well-defined description of an element of a set. It is given and the same are enclosed in curly braces. So from the word statement, for example, the set of odd numbers less than 7 is written as odd numbers less than 7. So the set of softball players with ages between 22 years to 30 years. So, naka-statement form siya. So let's proceed to tabular or the roster form. So in this form, we're going to list all the elements of a set separated by a comma and enclosed within braces or curly brackets. For example, let n denote the set of first 5 natural numbers. So therefore, what are the 5 natural numbers? So we have 1, 2, 3, 4, and 5. So in this form, it is in a roster or tabular form. The set of all vowels of all of the English alphabet. So we have A, I, I, U, O. So naka-roster form na siya. The set of all odd numbers less than 9. So what are the odd number less than 9? So we have 1, 3, 5, and 7. Okay, let's proceed to the last form, which is the set builder or rule form. Of a set, the element of a set is described by using a symbol X or any other variable followed by a colon, and a symbol like this and that is used to denote such that, and then we write the property possessed by the elements of a set and enclose the whole description in braces. In this, the colon stands for such that and the braces stands for set of all. For example, let P is a set of counting numbers greater than 12. So we have P in a set builder form written as P is equal to X such that X is a counting number and greater than 12. Or it can be written at this form. So we're just going to replace colon to this symbol. This will be read as P is a set of elements X such that X is a counting numbers and is greater than 12. For example, another example, let A denote the set of even numbers between 6 and 14. It can be written in a set builder form as, so X, A is equal to X such that X is an even numbers where X is greater than 6 and less than 14. So let's combine the three representation of set. The set of integers lying between -2 and 3. So between the -2 and 3, so we have -1, -1, -0, 1, 2. Okay, statement form. I is a set of integers lying between -2 and 3. Roster form. Set I is equal to -1, 0, 1, 2. Set builder form. Set I is equal to X such that X is an element of I, where X is greater than -2 and less than 3. Okay, so let's proceed now to the types of set. Okay, we have the empty set or the null set, finite set, and infinite set. So let us first discuss about the empty set or the null set. A set which does not contain any elements is called an empty set or the null set or the void set and is denoted by this symbol and is read as pi. In roster form, this symbol is denoted by the bracket. An empty set is a finite set since the number of elements in an empty set is finite. For example, the set of whole numbers less than 0. So clearly, there is no whole number less than 0. So it is an empty. This one. Set n is equal to x such that x is an element of n where x is greater than 3 but less than 4. So it is empty. There is no such natural numbers that greater than 3 but less than 4. This one. Here, A is an empty set because there is no natural number between 2 and 3. Okay, that one. Here, B is an empty set because there is no composite number less than 4. Note that this symbol has no element, but this one is a set which has one element, which is 0. The cardinal number of an empty set is 0. Finite set. A set which contains a definite number of elements is called a finite set. Empty set is also called a finite set. So definite, there is a definite limited number of elements. For example, the set of all colors in the rainbow. So there is a definite colors in a rainbow, right? We have the RGB. And then example number 2, we have set n is equal to x such that x is an element of natural numbers where x is less than 7. So what are the natural numbers less than 7? So we have 1, 2, 3, 4, 5, and 6. So the third example, we have this one. So it is limited to 97. Okay, first example. Then P is a finite set which have a 6 cardinal number. And number 2, we have, it is also a finite set and it has 24 cardinal number. And number 3 is 38. Whole numbers between 5 and 45. If we were to count that one, there are 38 cardinal number. let's proceed to infinite set, the last that I'm going to discuss to you right now. So the set whose elements cannot be listed, so it is to the infinite. We cannot count, we cannot list all the elements inside the set. Set containing never-ending elements is called an infinite set. For example, set of all points in a plane. Of course, we cannot count the points in a plane. Second example, x such that x is an element of natural numbers where x is greater than 1. So we cannot count the natural numbers greater than 1. Set of all prime numbers. Then last examples, we have x such that x is an element of whole numbers where x is equal to 2n. So it is to infinity. Examples of infinite set. We have set of all points in a plane in an infinite set. Set of all points in a line segment in an infinite set. Set of all positive integer which is multiple of 3 is an infinite set. And the set of whole numbers in an infinite set. The set of all natural numbers is an infinite set. And the set of all integers is an infinite set. So thank you. That's all for today. I hope you learned something. So again, this is Riena Nayra at your service. Bye!